applause for Sudhir. Just say.
I think, yeah. I know my voice is a little louder.
If you can't hear, just raise your hand and we can discuss.
Yeah. All right. Good morning, folks. As Anand mentioned, my name is Sudhir. I work as a senior technical evangelist with Microsoft. Before we get started, I would like to know how many of you on the database side? Okay, only 3, 4, 5. Okay. So today we're going to talk about dimensional modeling, which is related to the database side. How we're going to design. What are the key things that you need to keep in mind when you're designing a data warehouse? We'll talk about that. I'll give you a quick introduction. Why do we need a data warehouse? And why do we really care about dimensional modeling techniques to make a good data warehouse? Okay. So I also work on the Azure side. All the data services that the Azure has, be it predictive analytics, be on a batch analytics side, be it real-time analytics. I do work on those services, and there are a lot of services. I'm not going to name them because when I started my career on the database side, it was only SQL Server, database engine, right? And over the period of time, then business intelligence come into the picture, and then I get into that. And after that, it's data mining come into the picture. And now, if you look, there's the IoT is there, then machine learning is there, deep learning is going on, artificial intelligence is going on. And there are a lot of services, and then big data. I mean, how can I miss that, right? And if you even look at big data itself, there are a hell lot of services in it. Big, high, scoop, Kafka, HBase. You name it, it's there. So ocean itself, right? So that's my area to work on. Okay. Now what I'm going to do is let's move on to the next slide. Okay, sure, not a problem. Right. So traditionally, why do we need? Okay. So what happens is, you have your data sources available on the left hand side. That's your transaction database, right? And you keep storing data for a year, 2 years, 3 years, and so on and so forth, right? Now what happens is your users who are doing reporting on your data, they are hitting the same server or same database where your transaction load is coming in, right? So over the period of time, it's a bottleneck, right? Your applications start responding late. You will get throttling, you will get timeout errors, and so on and so forth, right? One of the way that you have is you can easily go ahead and scale up, right? You can add more power to the machine in terms of RAM, in terms of memory, in terms of the space, right? Cores, right? But is that the real solution? May not be, right? Because after some point of time, there is a capacity of a motherboard who can support the hardware that you keep putting into your system, right? So instead of that, the recommendation is take out your data, the data which is used for the reporting, and build a data warehouse out of it. Okay? And one of the benefits is when you're doing that, you are actually rerouting your business users, your reporting user to the data warehouse, okay, or the cube, which we'll talk about a little later. And then only the transaction load is hitting to your transaction server. Okay? The maintenance is going to be easy because now you separated two different things, right? You need to, one thing that you need to keep in mind whenever you're going to design or propose this, you need to keep in mind that you have to design the data archiving policy as well, right? How long your data is going to stay in the transaction database and when it's going to move out from the transaction and sits in your data warehouse, right? And that's what we call the staging area, where you bring your data in and you massage your data, right? It might so happen there are a lot of junk data which is available over here, which you want to clean it, all right? And then you push it into the data match, and that's the area we're going to talk about. And then from that, you're basically going to build the cubes over here, which is a cube, which is a multi-dimensional concept. So what you are doing now is, the aggregations that you're going to do on the cube is much faster as compared you're going to do the transaction database. Okay. Now I'm not talking about 10 rows. I'm not talking about 100 rows. I'm talking about billions and billions of records that you have. If you're going to do aggregation on that, it's going to take a lot of time on the transaction side. right? Because you have to do joins, you have to do grouping, you have to do sum, and all this stuff, right, in your query. But if you compare that to the cube, it's faster, okay? And why? Because the way it stores the data in it, if you, never worked on it, if you go underneath and see how the data lie into the data cubes, it's altogether different, okay? And then this guy over here is data mining, right? Which nowadays we call machine learning, right? So this is data mining. So if you want to do data mining, you can actually go and do that. Looks like a prediction, forecasting, market basket analysis, all these things you can do over here. And then at the end, you can present the data back to the user, right? Make sense so far? Are we good? Hold on. Yeah, please go ahead.
As you said, what will be the structure of data in the team that will be familiar for or that will be some pre-structured data. Like let's say, if I know, okay, I need these kinds of data or this kind of joins or this should be performed. So all this structuring has already been done and the data has been pre-structured and has been stored in this database.
Okay. In short, yes, and that's what we're going to talk about. How you're going to decide which part of the information is going to lie here or comes on here and in which format. We'll talk about that. So this whole session is going to all about that only. So towards the end, if you won't find your answer, I'll discuss with you more in detail. Okay? Yes, sir. So hold on. Yes, sir.
So what would you recommend? Like do a dual write, like one in the OLAP and one in the OLTP database, or like do all the writes, the application server should do all the writes into the main OLTP database, and then maybe end of day or like periods and that just moving to the web server.
Absolutely. The second one. So you don't want to, your application is keep sending the data. You don't want your application to send data to the data marts as well. Okay? That's a two-way write that you're going to do. Not required. You keep pushing your data over there. You have something called over here ETL tools, which extract out the data, massage the data, and push it over here. And then you refresh your cube over here. So pulling the data from your transaction database depends on your data archival policy that you have designed in a company. Maybe you want to move the data over the weekends when the load is less on your transaction, or maybe after the business hours.
One of the things I have usually seen with that kind of architecture is that almost always you want a reconciliation tool to make sure that whatever data you have in this database is equal to whatever data you have in the data marts.
Yes.
Or second, like the ETL jobs itself may be putting a lot of load on the OLTP database.
So that's what I'm saying. You have to figure it out what part of the day your business have a less load on your server, on your transaction. And that's where you're going to take out the data from there. And that also depends how much data you want to bring out from here, right? For example, if you're taking years of data, right? So things, it may put some load on your data source. But, first time it's going to be a load for sure. But the second time onwards, you're just going to take the data which is keep updating on your transaction database. You're not going to take the whole set of data again and again. So that's the idea, right? And going forward from this, big data, right? Where you can bring all the data, you don't need to massage, you don't have to do anything, and then you will figure it out. That's altogether a different game. All right? Same question? Okay. Same. All right. Cool.
So the
So
dimensions of the cube is nothing but the interesting attributes of the data, right? It need not to be a three-dimensional, it could be a multi-dimensional.
Cube is always multi-dimensional. I'm sorry?
Cube is three-dimensional.
No, it's a multi-dimensional.
Oh, it's called a cube.
It's called a cube.
It's called a cube, yeah.
It's not.
Oh, you're saying cube is a three dimension. Why is that what you're trying to say?
So it's a multi-dimensional concept.
Yeah, if you look the picture of it, that gives the feel of that it's a three dimensions. But actually it's a multi-dimensional thing. We don't have a good representation of how you can draw a multi-dimensional picture. That's why. That's the closest one. But it's not three dimensions, it's more than that. Right? And, huh? So cube is basically, it's a multi-dimensional storage mechanism, okay, which holds the data so that whenever you wanna do any reporting, for example, I want to get the data for particular year, for this particular product, for this particular city, it knows in which dimension it has to go and pick the value from there. So the way it stores the data in the cube is altogether different how it gets stored in the transaction database. Generally, your transaction database stores data in a row and column format. That's a two dimension you can think of. But when it comes to the cube, this is how it is. Okay, you have a drive, C drive, D drive, E drive, right? That's the one dimension. In the D drive, then you have second dimension, your folder structure, right? The third dimension then is going to be your Excel file, for example. There are a lot of Excel files. That's going to be the third dimension. Fourth dimension, when you open that file, you have sheets in the files, right? So that's the another dimension. And then under that you have some value in particular cell. This is the column number and the row number, right? So this is how actually you can think of how data gets stored in a cube. We can talk about designing of the cube later stage, maybe in the next session, whenever time asks. But right now we're going to focus on how you're going to design this part. Because this is very important. If you don't put data warehouse, good data warehouse in your system, then it might happen that you have to do a lot of calculation over here. And it's not easy. Okay? Because querying a two-dimension data, which is a SQL server or any relational database, you have a SQL queries, right? But when we talk about multidimensional, we have something called MDX, multi-dimensional expressions, right? So think about writing a SQL query. Nowadays it's easy, but earlier days it's not, right? People used to think how to write join and so on and so forth, right? Think about you have multi-dimensional now. How complicated it's going to be, right? And there are no much experts on MDX. Nowadays not required, but earlier days there was not much experts you will find on MDX. It's that complicated.
When you think about cubes in transaction itself, along with the data archivers, and we have a data cube serving purpose in transaction for part of the cube.
No, it's not meant for that. It's not meant for that.
Because watching the data and data of
yeah, so if you have a huge amount of data, 5 years, 10 years, 15 years of data, and you want to do reporting on that, that's where you're going to look into this. Because your transaction is basically meant for high read and write. Right? So transaction
reporting also on transactions or sometimes we do, right?
People do because they have less data, right? And they have enough power for the query execution, right? But that's not always the case. As you grow, as your business grows, as your user grows, you'll have a lot of data coming in your transaction. And one point of time you'll start hitting certain problems. Right? Either you can wait till you hit the problem, or you can be proactive to design this architecture.
Sudhir,
Yes, sir.
Question regarding queue. So queue is actual storage or just the schema on top of all these?
It's both. It's both. Without schema, it doesn't know where I need to figure out a particular value. So for example, in an Excel I have a row column, a cell, a value, let's say 100, right? If I tell I need 100 value, it doesn't make any sense until and unless I tell this is the folder, this is the file, this is the worksheet, and this is the row and the column number from where I want the value, right? Because the value can be duplicated. Until and unless you know the address, in other words, you can't reach there, right?
Actual data will be here in data store, whatever it is.
So that depends. So Cube has functionality. You can have partially data over here, or you can have your data lie in data warehouse as well. That depends. How you going to configure your Cube, it totally depends on that. Okay. So probably next talk, if people are interested, we can do it on the Cube. But right now, we'll talk about on the dimensional model. Makes sense? Any questions? Okay, cool. So let's move on to the next. So when you start dimensional modeling, there's a two approach to it. Okay. One is Bill Inmon's approach, and the another one is Ralph Kimball's approach. Okay, and I'll tell you the difference between that. Okay, now Bill, and nothing wrong with any of these approaches. It totally depends, but most of the enterprises you will find Ralph Kimball's approach applied. Okay, so what it says, Bill Inman says, we're going to have one data warehouse. Okay, all the data will reside over here. Then we will create a data marts. Okay, so let's say if I have a different department, right? Finance department, HR department, production department, and so on and so forth, right? So what I'm going to do is I'll have a different data marts for them, which is you can think of one database itself. Okay, and behind the scene we have a data warehouse, right? So all the data will flow from data warehouse to the data mart, and then will go to the production team. Okay, so wherever they are storing the data, we'll take the data, we'll push it into the data warehouse, and then it will come into their data marts for the reporting purposes. Okay, so that's the approach. So if I go back to the previous slide, so they will go with this way. Rather than coming this way, which is the Ralph Kimball approach, they will go this way. Okay, so your client will be that side, and then they will connect it to these data marts over there, and then you have a data warehouse in between. Okay. Whereas Ralph Kimball says you're going to have your data warehouse, right? So all your users will enter the data into traditional databases. All right, like it's happened nowadays. Every transaction goes into the database, right? And if you, for example, if you look at the point of sale systems, all these have their own data marts or small databases, right? And they'll keep sending data into that particular database, right? Now, at the end of the day, they will push the data into the data warehouse. So similar thing, all the departments are connected to the database, and then at the end of the day, they will push the data into the data warehouse, and then you can do the reporting on that. Okay? So when you go into the field, you will hit both the approaches. And again, there is nothing wrong with either of these approaches. But most of the enterprises, you will find the second approach applied. Okay? And we are going to talk about the second one. Okay? So let's go ahead and talk about what are the design processes is, what is how you can design the dimensional model, and some concepts about it. Okay? So this is how the process for designing dimensional modeling goes. Okay? The first of all, you have to choose the business process, which is very important. For which business you're going to design a data warehouse or the cube. Okay? It could be a sales department, it could be a HR department, it could be a finance department, production department, or it could be anyone. So first thing you have to define that. Okay? And in the same step, you're probably going to define related facts and the dimensions. What is fact, what is dimension, we'll talk about in a couple of minutes. But these are the tables that you're going to identify for each of the processes. Okay? The second step is identify the granularity. That means what is the lowest level of information that you're going to store in your data warehouse. Okay? For example, and I'll tell you the benefit of it. So for example, the daily transaction happening, I'm inserting this daily records into the data warehouse. Okay? Now if I'm doing that, the granularity is a day level. If I'm going to do that, tomorrow I can give you an answer and say, this is the day-wise sales. I can tell you what is the daily sales, that's the aggregation of the day-wise. I can tell you the weekly sales. I can tell you the monthly sales. I can tell you the yearly sales. Right? Because I have the granular level data available with me. However, let's take an example. If I am the granularity I have set at the month level, okay, and somebody asks me now, give me the weekly sales, I can't, right? Because that level of information I'm not storing in my data warehouse, right? So you have to be cautious about it. The granularity as well is very important. Make sense? Okay. Identify the dimensions. So one other thing is in the confirmed dimension, which we'll talk about. But the idea is, if you are designing designing a data warehouse for business processes, for example, HR and finance. Okay. Now both the department requires employees information. Okay. But it's common, right? Which is a confirmed dimension. Now what is dimension we'll talk about little later. But that's the one piece of information which is common across both the business processes. So that employee dimension will become your confirmed dimension. That this dimension will anyhow is gonna stay in my data warehouse. Okay? And then you're gonna identify the facts. Alright, so let's move on to the next step. So this is your dimension and fact table. Okay? Your fact table generally keeps the information, the numeric information in it. Alright? If I take an example of designing a data warehouse for the sales, I will have order quantity, total product cost, sales amount. All these numbers I'm gonna keep it in the fact table. Okay? And then I'm gonna have dimensions, which is product dimension, time dimension, and so on and so forth, which is connected to my fact sales table. Okay? Now here the idea with the star schema, here the idea is try to denormalize the things over here. Alright? Because we're going to use this information for reading the data. We're not interested in writing the data because we're just going to read the data over here. Right? So that's called the star schema. We have one fact table associated with the respective dimensions table. Okay? And you can see the product key we have. So here's a dimension. Order date key, we have a time dimension. Right? And similarly, employee key, we have an employee dimension table as well. Okay? So one fact table is connected with their dimension table. However, there is another schema which is called snowflake schema. Snowflake schema, okay? Which you try to avoid when you're designing your data warehouse, and the reason is, as soon as you introduce snowflake schema in your data warehouse process, again you're trying to do a normalization. You're adding more tables. So for example, here's my product. Okay? In the product, I'm going to add product category, product subcategory as well. Okay? So if I have a milk, then probably I'm going to say, okay, which brand of milk, Amul, Nandini, and so on and so forth. And under that, then I'm going to again bifurcate by low fat milk, full fat milk, and so on and so forth. Right? So you're going to have 3 different tables. So your fact is defined connected to your product, then product is connected to another table, and that table is connected to another table. Right? So you will come from milk to which company milk I'm talking about, then what is the product key that I'm talking about, and then what is the total sales. Right? So that's how the query. Again, you're going to join the query. Somebody asks you, what is the total sales of a particular milk? Right? Try to avoid. In circumstances, it's not possible, to avoid snowflake schema. Then it's good, but try to avoid that. Okay?
So, just to understand it.
Hold on, sir. I think he raised it, so I saw him first. Hold on. I'll ask you.
So last that you said set category, that is also.
Yeah, so it's going to be the same. Then you're going to have div product, then you're going to have div product subcategory, then you're going to have a product category table as well. So there's 2 more links will connect over here.
Yeah, in the similar line, I think. I was trying to understand Snowflake's clear star schema. So there also we are having parent-child relationship kind of thing, right? And runtime just we are.
But that's in a multi-level, right? For example, again, so here I'm storing, for example, fact receiver sales information, okay? And I'm just storing the information about a product, for example, water bottle, okay? Now, which water bottle it is? Bisleri, Kimberly, Himalayan, right? I need to store that information.
Yeah.
One way is you can store it on this table, or you're going to create another dimension table because that will have more attributes to it, right? As soon as you're going to add more tables to it, it will take a picture of a snowflake. I mean, like the product, and then it will have additional table associated with it, right? And then if you want to calculate some sales value for products, then there are 2-3 hops for you to come down over here, right? because you'll go for product category, subcategory, then to the product, and then to the sales.
I
That's
guess
how it
what
is.
you are trying to say is that in warehouse you usually want like denormalized data, but not too denormalized.
Correct.
And not too much like normalized data also.
Huh.
Otherwise you have joins.
Correct. So too many joins is not good. It's not good. That's not good. But there are some, as I mentioned, there are some business requirements, even I face that, where there's no other option that you have to introduce Snowflake schema. Alright?
So
I could have been avoided, but I just want to tell you that Snowflake schema is also exists, and that's the the advantage and disadvantage of introducing Snowflake schema in your design. Yes, sir.
So for read optimize, what is the preferred schema? Because the data warehouse is all about reading. Right? So
Data warehouse is all about
reading.
yeah.
So for read optimize solution, what is your solution? Star schema or Snowflake?
Star schema. As I mentioned earlier, as you get into these Snowflake schemas, you will introduce more joins into it. And as soon as you're going to do that, obviously your query will take more time as compared to the direct query.
So here also I'm seeing joins, right? In the fact table, we are having all keys from different tables.
Correct.
So when I looking for report, it's a span across the table. Again, there will be joins.
So I'm not, so what happened is this connected to the cubes. This guy, so I'm going to use this structure to build my cubes. And cubes will extract out information from here to store the information either in it or maybe he's going to use it from here itself. So that time, the processing is going to be faster for the cube. That's the one thing which I'm trying to avoid because it will be good for me to talk about cubes separately. But since you brought up, you don't want to do that because when you're going to process your cube, it's a huge amount of data which is already lying in your cube. When you're going to say I'm going to process the data in the cube, sometimes it takes a day to process the cube. So that's another aspect of it.
I think the warehouse what you're looking for like the ideal case is just having like single like flat spread.
Huh.
But then
Yeah.
like if you want to look at certain views, you have to do a lot of group wise, which is again expensive. So that's kind of
Okay. All right. So these are the various benefit of having a star schema as compared to the Snowflake. Now let me just get into the dimensions. Okay. Now, whenever you're going to design a data warehouse, the one thing is you're going to talk to your customers and you need to set up a multiple meetings with them. It's not going to happen that the first meeting you will say, okay, I have completed the requirement and I'm ready to design my data warehouse. It's not going to happen. It's not going to build one day. Sometimes I have seen people take 6 months to design a data warehouse. Right? So it will take some time to understand. There are a lot of things which goes in over there. Figuring out the dimensions which is required for your business, right? And how you're gonna actually define what is my dimension, right? So it basically defined by the word by. Okay? So if my user says, I want my reporting by product, so my product is gonna be one dimension. My user says, I want my reports to be available by time. So I have a time dimension as well. Okay? If it is an HR related software, then probably somebody says, okay, I want my information by employees, alright, or maybe sales organization says, okay, give me the information about by employees, how many sales that they are doing it, right? So each will become your dimension. Any questions? Pretty straightforward, right? So you will basically figure out the dimension by meeting your customer, and whenever they say we want to do the reporting by this, by that, that will become your dimension. And what the dimension is going to store is basically the information. For example, DIM product, it will have the key and it has all the associated column information, what we call attributes. So I have a dimension, product dimension table, and it has a key plus its attributes. Right? What is the size, what is the color, what is the description of the product, and so on and so forth. Okay? So you will keep this information which your user requires. Because when you look into the transaction, it might so happen that you are storing a lot of data about your product. That means there might be so many attributes that you are storing in your transactional database. But all the attributes you may not require for the reporting purposes. So you need to eliminate those columns which is not required, because you don't want your data warehouse to take a lot of space, right, in your data warehouse. So extract out the attributes which is not required and bring only the attributes which is required for the reporting purposes. Okay? And
Again, sorry to interrupt you.
go ahead.
Maybe in future we will need some more column, those attributes.
Huh? If
Future,
in future.
yeah. So why not we should eliminate all those attributes?
No, in future
Again,
you
we
may.
will design a new dimension if new requirements comes up.
No, that totally depends. So what happens is, if you're gonna bring something new, later point of time, you can either bring it on to the existing. If you have existing dimensions, you can go ahead and put it into the existing itself. Somebody says, I want to add a new attribute. Go ahead and add it into your existing dimension table. Don't create one more dimension table. Okay. Right. All right.
Each dimension table will have one primary.
Each dimension table,
Will have one primary.
one
Not
primary.
be normalized.
It will have one key. So that's how the dimension table, the definition of dimension table, key plus attributes is equal to your dimension. Okay? And that's where your dimensions come into the picture. As you can see, this is my fact information, this is my dimension information. This is my date dimension table. I can actually go ahead and drill down, drill up as I want, depending on how I'm storing the data in my dimension. Okay, we will talk about it a little later. But the idea is, your dimensions provide context to the numeric values which is deciding in your fact table. Okay? If I don't show you this side, will you be able to figure out what it is? If I remove this, okay, remove this guy, and I say this is a sales amount and sales amount quota. Will you be able to figure it out what these numbers means? No, right? You need a context to it, the context to the numbers. So that your dimension will bring into the picture. So you need to have your dimensions. Does that make sense? Right? Okay. So this is a snowflake schema design which I was talking about. So you have a product category and then product subcategory, and then you bring on to the product, and this product will now further link to your fact table. Right? Okay. Very important. So you can define primary keys in the dimension which we already talked about. So your dimension table will have a key plus attributes. Okay. So there's two things that you can do. One is you can actually go ahead and rely on the business key. Okay. That means the key which is acting as a primary key in my transactional database. Okay. If I take an example of a product, in my transactional table I have a product table, right? In the product table I have a product ID and its various attributes, right? So one thing is I can actually go ahead and use that. That's called the business key. Okay? And the other way is create a surrogate key. That means you create a new key when you are getting the data into your data warehouse. Make sense? But why? Why can't I rely on the business key? Right? This is a unique value. Right? Why can't I stay with business key? Why do I need a surrogate key? And I'll tell you in a couple of minutes why do we need a surrogate key. But the surrogate key, it could be your identity column which you keep increasing as the new values coming into your data warehouse. Okay? So that's your surrogate key. Okay? Or you can actually go ahead and design your surrogate key based on maybe combination of some keys in your data warehouse or maybe in a transactional database. So that's totally up to you how you want to design your surrogate keys. Okay? Alright, now let's get into the fact tables. So your fact tables basically consist of the foreign keys from your dimensions and the measures, that what we call the numeric values. That's the two information that your fact table is gonna store. Numeric values plus foreign keys. That's all it's gonna store into it. Okay? And obviously you need to have the granularity defined as we talked about earlier. Okay? So there it is. Okay? So now on the left hand side you can see, or maybe right hand side, this is an example of fact table. I have the foreign keys and then I have my measures in it. Okay? And granularity you can see one is quarter and one is day. If you go to the quarter side on the right hand side, if somebody asks you what is the day by sales, you won't be able to give it because that information is not available. So the granularity is not there. Okay? Foreign keys, which is we talk about, I need to go a little quick. Then we have something called factless fact table. Okay? So I'll just take 5 more minutes. So what is factless fact table? The factless fact table means the table which does not contain any facts in it. It only consists of keys. There are no measures in it. Only keys is there. For example, if I'm basically creating a data warehouse for attendance, right? So I'm going to have employee dimension, I'm going to have date dimension. Okay? But in the fact table, what I'm going to store? Whenever the employee is present, I'm going to have the date key and I'm going to have the employee key. And that tells me whether he is available in the office. Right? I don't need any numbers. So that table will become your factless fact table. Okay, which will only consist of keys, nothing else. So there's another thing you can actually go ahead and so there's a date dimension table which is it's going to be a confirmed dimension because you go any business for designing a data warehouse, the day will become the date will become a one of the dimensions for reporting purposes because everybody wants to see data monthly, weekly, hourly, and so on and so forth, right? So I have to go a little quickly. Let me just move the important point. This one. Okay. So we talk about dimension, we talk about facts, right? Now what happens if my dimension value gets changed? Okay. Generally your fact value doesn't gets changed over the period of time because when the sales has been made, it's made, right? And your data, according to your data archiving policy, you will bring the data after your returning, policies expire and so on and so forth. So that means there is no chance your data will change, at least the fact, the sales amount value, right? But your dimension value can change, right? Today the product name is something else, I can add something to it. Employee names can change, right? So we have something called slowly changing dimension, 3 types, quickly go through with it. So one is, you can actually go ahead and update the existing record. Okay? So that means you are not keeping the history of the records. If somebody asks me what is the last name of employee Rachel before Val Smith, I won't be able to answer. Right? It fails. Right? Because that information I'm not capturing. So I have employed the SE slowly changing dimension type 1. Right? So whenever you're going to push your data into your data warehouse, you're going to check if it is the existing, you're going to update the existing record. Otherwise, you're going to insert a new record. Okay? Now, if somebody asks for the historical information, so now what you can do is, you can actually go ahead and have 2 more columns in it, 2 more attributes, start date and the end date. Okay? And then you can actually update the record over here. So with this, you can actually track the changes that happens with the employee. So today, employee is doing sales in an Australia region. Tomorrow, he moves to the India region and then US region. You don't want his reporting to go here and there, right? So whatever sales he does in Australia, it should reflect in Australia region, right? How are you going to find out? If you don't have this, you will lost somewhere, right? So this will keep track of the changes. And here's the surrogate key that I'm using. Now, if I use business key over here, right, which is the primary key of the transaction database, the insert will fail. Primary key constant, right? 296 again want to come in. Here, let's say 294. Again, he wants to come in. But it will fail, right? So that's where you need a surrogate key. Okay. And this is the type tree, which will just update the existing value, but you can have a limited information. So one step back you can tell, but beyond that you cannot tell because it has one more column added. It's just you need to add more columns based on what type you want to use. Okay. Real quick, I'll just show you one this particular Excel sheet. Okay.
So we use pivot table in Excel sheet. So we are actually doing the data warehousing, right?
Huh?
We use pivot table in Excel.
Sort of behind the scenes, yes, you are. Yeah. And that's an in-memory concept, which I can talk about a little offline. Maybe we can take it off. Okay. So here, when you're designing your data warehouse, what you can do is, when you talk to your customers, go for the requirement gathering. You can actually create Excel sheet, and you can create your dimension. For example, I have this customer dimension, right? And then I'll record all this information over here. Okay. So one thing is I'm maintaining how my data warehouse is designed, and as well it will be helpful for my organization to figure it out. You know how this design, if somebody new person comes in, he can actually look into that and so on and so forth, right? So table name, table type, everything, and then column or the attribute names are there. Okay. Data type, description, everything is defined over here in the Excel. All right. Similarly, you can define the fact table as well. All right. What are your keys? What are the measures that you want to record into your fact table? Right. Now, once you're done with that, you can actually go ahead and go back into the home. You can actually go ahead and update your diagram as well. Or you can actually generate a SQL script. So when you create a diagram, it basically tells you how your facts and your dimensions are related to each other. Okay. So we'll get a very nice diagram which will give you this information. And when you go to the generate SQL script, it basically gives you a entire SQL scripts for creating your data warehouse. All the tables, you will get it. So I'll just quickly click on that, and if you have any questions, we can take it. Otherwise, we'll.
Can we download this Excel, or are you going to share this?
I will share it. I think it's available online. Okay. So here, you will see it has all the information about table creation, your dimension table creation, your fact table creation. All will get in. Okay. All right. If you have any questions, we can connect on LinkedIn, or maybe you can drop in an email if you want. And I think I'm done. I can take any questions if you guys have.
What is denormalization? Denormalization. Typically, they say the data warehousing is like denormalized. The database is not denormalized. Normalized.
Database is normalized.
Yeah, it's
Correct.
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 But data warehousing you have to denormalize.
Denormalized. Yes. So Bill Eamon's approach works on you when you design a data warehouse using that approach. You need to apply third normal form to it. But whereas Ralph Kimball try to denormalize as much as you can. That's the objective, which is reverse of when we're designing a transaction database.
That is where we can answer all the possible business questions, right?
Yep. Yes. If you capture your business requirement well, if you design your data warehouse well, you can go ahead and answer whatever they want. Yeah. Yeah. All right. I think I'm done. Thank you. Thank you very much.